Hi there, welcome to my channel. In this video, let's solve this interview problem. And the question is to populate next right pointer in each node. And here we are given with a binary tree and we have to make it look like the right side of the diagram. So in this tree, on each label, we have to make it to point to the next node onto the same label. And for the last node, we have to make it to point to null. And you can see this one is the next pointer of this particular node will be null. Similarly for 2, 1, it will be pointing to the third, and this third will be pointing to null. Similarly for the third label. So this is quite a simple program. If you know the tree traversal, then it's just a variation of BFS. So let's see how to solve this problem. So I'm going to write a BFS algorithm first. So here I'll just put a null check. If this node is empty, then I'm just going to return null. Otherwise, we are going to write a BFS algorithm. And for BFS, we use queue basically. So I'm going to create a queue with a root element as the first element, and I'm going to traverse this queue. If you're not familiar with BFS, you can watch my previous video in this playlist where I have explained the BFS. And here I'm going to iterate it till the queue is empty. And here I'm going to take the length of this queue. And again, I'm going to iterate it. And here I'm going to take out the element from queue. Let's call it temp. And I'm going to use shift here. This is a function in array using which we can take out the first element from the array. And now if left element exists, then we are going to push the left element to the queue. Similarly for the right element. So we are kind of done with our BFS algorithm. Now let's modify it to adopt this change. So here we want to point the last element to the null node. So we don't have to do this explicitly because by default, this next will be pointing to null only. So we don't have to explicitly do it. We just have to focus on this particular intermediate nodes, which has to be pointed to the next element. So here we have to point all the nodes to the next node on the same label, except the last nodes of each label. So we are going to write a condition here. So we are going to choose if the particular index is not the last index. Then I'm going to fill the next pointer here. And here I'm going to put Q0. So now let's run through this program and see what is happening. So first of all, we have a queue. And here the first element we are pushing is root. So we have 1 in our queue. After that, we are iterating through it. We are taking the length and then we are taking out the first element. So we are removing 1 from this queue. After that, we are checking the left element and the right element. And if it is there, we're just pushing it. So we have the left one. So we are going to push 2 here. After that, we are going to push the right element. Then here we are checking if this I, in our case, it's 0 and the length was 1 at that time. So 1 minus 1 is 0. So this condition doesn't satisfy. So we didn't update the next pointer. So here we are not touching the next pointer. It's already been pointing to null. So the second iteration continues. In the second iteration, the length is 2 now. And we are taking out the element. So we are taking out 2. Then we are checking the left and right element and we are pushing it. So here we'll be pushing 4 and 5. Then we are checking I less than length. So in this case, I is going to be 0 and length is 2. So 2 minus 1 is 1. This condition satisfies. So we are updating the next pointer of this one, of this particular element to Q0. And right now Q0 has this element and its Q. So now this will point to 3. After that, the iteration will continue. This time the I value is 1. It will come here. We are taking out 3 after this step and we are pushing left and right. So we'll be pushing 6 and 7. Then this condition won't satisfy because the length was 2 and now the index is 1 here, 1 less than 1, which is not true. So this condition won't satisfy. Then this iteration continues. We are just taking out 4 from here. We have 4 here. Then we don't have anything. We will not push anything. This condition will satisfy. Then we are pointing 4 to 5. So similarly, we are doing for all these nodes. So this is how we are solving this problem. So now let's complete this program. At the end, we have updated all the next node. So we just have to return the root. Now let's run it and see. So it's done. The answer is accepted. And if we talk about the time complexity for this whole BFS algorithm is order of n. So that's all for this video. And if you find this video useful, don't forget to like, share, and subscribe. And I'll see you in my next video. Thank you.